In this video, we are going to determine whether the following series converges or diverges. So here we have the sum from n equals 1 to infinity of n over e to the n. So we are probably going to want to use the ratio test here. First, let's recall what the ratio test is, and then we'll talk a little bit about why it makes sense to use it. So the ratio test tells me that suppose I have a series where I'm summing up some an, and I define the limit L, where L is the limit as n approaches infinity of the absolute value of a sub n plus 1 all over an. So I'm defining this limit. If L is equal to that, then depending on what L is, we can tell whether a series converges or diverges. So first, if L is less than 1, then the series converges. Now, if L is greater than 1, then the series diverges. Lastly, if L is equal to 1, then the series may be divergent, conditionally convergent, or absolutely convergent. So this is kind of inconclusive. Now, in our case, an equals n over e to the n, and a sub n plus 1 is equal to n plus 1 over e to the n plus 1. So the reason we might want to use a ratio test for this is because if I do an plus 1 over an, I'm going to get some cancellation and I'll get a nice limit. So I guess one of the telltale signs for this problem is that I have something raised to the nth power and then n over that. So an plus 1 over an is equal to n plus 1 over e to the n plus 1 all over n over e to the n. So this is equal to n plus 1 over e to the n plus 1 times e to the n over n. Now let's determine what L is. So L equals the limit as n approaches infinity of the absolute value of an plus 1 over an. So that's going to be n plus 1 times e to the n all over, I'm going to write the n terms over each other and then the e terms over each other. So this is n times e to the n plus 1. Now we see that we can simplify this a little bit. This is just the limit as n approaches infinity of the absolute value of n plus 1 over n. And here I have e to the n over e to the n plus 1. So that is just going to leave me with an e in the denominator. Great. Now as n approaches infinity, this n plus 1 over n really behaves like 1. And so this limit, I'm going to be left with a 1 over e. So as n approaches infinity, this limit is equal to 1 over e. And so this is less than 1 since e is greater than 1. And that hits the first criteria. So we can conclude that the series converges. If this video was helpful, please like and subscribe. And if there are more problems you'd like to see solved, feel free to email them to ashmath1729@gmail.com.